Okay. All right. All right. Now we're recording. So number 12. Okay, number 12. The sum of a certain number and 3 times the number is 40. So what is that number? Okay. Now let's take let's copy this and let's go to my teacher board. All right. Boom. All right. Let's okay, so a sum of a number. Okay. So a sum of a number, the word sum means what? What does sum mean?
One of those numbers, the sum of one of these numbers.
So sum means that we're going to add. So the sum of a number, okay, so we're going to be adding. That's 3 times the number. So 3 times means, so we know we're adding. 3 times a number. So 3 times a number, we could write like this. 3 times the sum of a certain number and 3 times the number is 40. So let's think about it. Let's see if this makes sense. So altogether, it has to equal 40. So the sum, that means add, of a number, we don't know what that number is, and 3 times of that same number is going to equal 40. So what is the number? Okay, so if this is correct, I know that x plus 3x is going to be what? What's x plus 3x?
4x.
That's right. It's going to be 4x. Okay. So if I know that in order to find x by itself, I have to divide both sides by the number in front of the x. So what does that look like? So I'm taking the number in front of x, which is 4, and dividing both sides by that number. Okay. So I'm dividing by 4.
Okay.
And I'm dividing by 4. Okay. 4 divided by 4 is going to give me a whole number. And 40 divided by 4 is what?
Ten.
So x has to equal what?
10.
Okay. Now,
okay, that makes sense.
How we get there is we got to understand with word problems, we got to understand that this thing, sum means add. And the number that we end with is what we have to, in this case is 40. That's the number that we have to set everything equal to. And there's plenty problems that
I just didn't get if it was telling me that if I had to like add the number to itself and then multiply it by 3 or something.
Yeah, it can be kind of tricky. That's for sure. Okay, let's go back to the questions here. Okay. Okay.
17.
17. Let's copy this. Bring it over to the teacher board. Okay. Let's take a look at this. So if B is 1/2 H times M, solve for H. Solve for H. Okay, so I could write this. I could write this. Almost forgot my laptop's not touchscreen. I'm touching the screen on my laptop. Like, oh, it's not working. So B is equal to 1/2 H times M. And we want to get H by itself. Okay. All right. So what would you do? What do you recommend that we need to do in order to move the M to the other side?
Put it with 1/2.
Okay. Well, think about it. When I take a look at M and I take a look at H, what operation is going on here? Am I adding? Am I subtracting? Am I dividing? Am I multiplying? What am I doing? What is M doing to H? Okay, you're right. So what's the opposite of multiplication?
Division.
Division. So I got to divide to undo multiplication. Whatever I do to one side, I do to the other side. Okay. All right, now I'm going to ask the same question here. What am I doing to, when I have 1/2, what am I doing with the 1/2 to the H? Am I adding it, subtracting it, dividing it, multiplying it?
Multiply.
I'm multiplying. I am multiplying, okay? So I undo multiplication by dividing. Well, in this case, we just need to know that when we have a fraction and we divide, we just have to take the inverse. So the numerator and the denominator switch positions. That way, 2 cancels out with 2, and the 1 cancels out with 1. All right? So in this case, I have 2 over 1. So I can rewrite this now, right? I can rewrite it where I have H is equal to, move this down here. So H is equal to 2B, or not to be, right? 2B or not to be. 2B, and I'm dividing it by the M. So in this case, our choice is A, B, C, D. What's the most correct choice?
Could you explain that one more time? You were kind of breaking up.
Sure, I can explain it one more time. Okay, so in order to get from here, where we started, to here, where we ended, we understand we're trying to solve for H. That's what they told us that we were looking for in our directions. We're trying to solve for H, okay? So in order to solve for H here, what we have to remember is that whatever the operation is that we start with, we got to take the opposite operation. In the case of M, the opposite of multiplication is dividing. So I got to divide both sides by M. So that's what we had here. And then we have to take the opposite of 1/2. The opposite of 1/2 is 2 over 1. So 2 over 1 on the right, 2 over 1 on the left. Let's see what's left when we, take a look at what we have canceled out now. So we've canceled out the 1, canceled out the 1, canceled out the 2, canceled out the 2, canceled out the M, canceled out the M. What's left is H. So because we like to write our variable from left to right, I'm going to swap the H from this side to this side. Okay? And then I'm going to read from left to right. 2B over 1M, or in this case, I'm just going to write M. So H equals 2B divided by M, which is the same answer we find in B.
Okay.
All right. This is not a hard question. It just requires you to know your order of operations and to realize when we want to move from one side of the equation to another, we have to undo whatever the operation is. If I start by adding, I got to now subtract, and vice versa.
Okay.
Okay. All right, this is good. I mean, we got some practice problems in. Let's keep going here. All right.
21.
21.
Now, the thing with this is that I'm unsure. Like, I know you're supposed to combine like factors, but I'm not sure if like the order has to stay the same.
Okay, I got you. All right, well, I'm gonna give you kind of maybe one way to keep it organized. Crazy thing about math, there's no shortage of different ways of doing it. It's just about which way is the most comfortable for you.
Okay.
So nothing that I teach you is a requirement. It's just a recommendation. Okay. All right. So let's get that new problem pasted in here. Okay. All right. So again, recommendation. When I see a problem like this, what I know is, I have a couple different variables. I see I have an X, a Y, that's another Y. I see I have a Z, all right? And then so I have an X, a Y, and a Z. X, Y, and Z. And sometimes, I'll get real fancy and I'll kind of put them in columns. But this is a nice, easy way for me to keep things organized. Okay, so I'm gonna go right down the list. So my first one was 3x, positive 3x. Okay, next one is negative 2y. And what I'm gonna do is I'm gonna stack these terms together. This is called the stacking method. Next term, positive 3z. Next term, positive 2z. Okay. Negative 4x. And then finally, negative 5y. All right, now before I go further, have you seen a method or a chart like this before? Dorian?
You asked me if have I seen a graph like this?
No, have you seen a chart like this before?
No, I had.
Okay. Do you understand how I made the chart?
Yeah.
Okay. So if you understand how I made the chart and how, it's really just designed to be able to group things together. All right. What would be our final answer?
Um.
Would it be A?
Yeah. Okay.
Okay. So if I take a look at A means that my X has to be a positive term. Well, what do I know immediately when I look
Oh
at
no,
my
it's a T.
X's? So it can't be A, right? Okay.
No. What?
Okay. Can't be A, right? Because we know that my A
No.
has to be a negative term. My X's have to be a negative term. Okay. Okay. So how about C? Would it be C?
It's D.
You say it's D. Okay. And it's D for what reason?
The two Y's
Mm-hmm.
cancel each other out, so you only have -5 left.
Mm-hmm. That's true.
And then the Z is positive.
Mm-hmm. Boom. There you go. So if you can get very good at using this stacking method, it's all I call it. I call it the stack method. All right, you stack them together and you see what
Okay.
falls out. Okay, you stack it.
Yeah, this is cool.
Okay, all right. Let's see the next problem.
And then 28.
28. There it is. Okay. All right, so this question reads, find three consecutive, ooh, that's a nice word, three consecutive numbers such that 3 times the first is equal to 8 more than the sum of the other two. Ooh. All right. So we know that consecutive means one right after another. Okay.
Yeah.
All right. So each one of these A, B, C, and D look like consecutive numbers. So that was the first criteria. Okay. So the next criteria, such that 3 times the first number, so 3 times the first number, so 3 times 8 would be what?
24.
Okay. So let me just write this down here. So we're going to have to do 3 times, I'm going to put the idea of A. 3 times, A would be the first number. 3 times the first number is equal to 8 more than the sum of the other numbers. So the sum of the other numbers would be, you say that B is 9 and C is 10. Okay. and it's 8 more. Okay, so let's define these terms. So A, we're going to let A be the first number. We're going to let B equal the second number.
Mm-hmm.
We're going to let C equal the third number. Okay. Now, it says that 3 times the first number should be 8 more. So what they're basically saying is 3 times the first number should be equal to 8 more than the sum of B and C. So that's how we want to actually write it. And then what we're going to do is we're going to guess and check. Okay. We're going to guess and check. All right, so let us create our table. Let's create our table. All right, and so, okay, all right, true versus false. Okay. True versus false. Okay, and this is our options. So we're going to look at option number 1. According to option number 1, if I take 3 figure that out. If I take 3 and I got to multiply by 8, all right, that should equal 24. Okay. Now I'm going to add 9 and 10 together. 9 plus 10. And that should be 8 more. Okay. So 24 doesn't equal 27, correct? With me on that?
Yeah. Yeah.
All right. So because 24 doesn't equal 27, okay, we can say false. The first one is false. Now we're going to check option 2. And so really what I'm doing is I'm doing a method that's really old. It's called guess and check. Guess and check. Right. The calculator is really cool because it saves me some time. I don't have to retype anything. I just highlight what I typed before. Now I'm going to take 3 times 9. That's 27. Okay. All right. Now I got to take 10 plus 11 and add 8. Well, I kind of see already that's probably going to give me a different number. That's 10. That's 11. All right, in this case, I got to retype. That's no big deal. Okay. That's 29. Okay. Boom. Too big. That's also going to be false. Okay. Then we continue to guess check. Okay. Now we have 3 times 9, or 3 times 11, right? 3 times 11.
Uh-huh.
That gives us 33. All right. Then we're going to do 12 plus 13 plus 8. Not minus 8, but plus 8. Wow. There we go. 33. Okay. So it took our third option for us to get a true. Okay. So let me kind of summarize what we basically did. First of all, we had to convert
Okay.
the numbers, the English words into numbers. And sometimes that's hard. All right. If you don't know what 3 consecutive numbers means, that you're at a disadvantage. If you don't understand 3 times the first number is really 3 times the variable, and we let that first variable be A. And if we didn't understand that we have to take the second and the third variable and add them to 8, then it almost becomes impossible to do. But once we get that done, all we're doing is guessing and checking. And the best way of guessing and checking, in my opinion, is to create a table. If you don't create a table, your work gets very sloppy. And when you have sloppy work, it's hard to remember what you were doing. Okay. Sometimes I'm grading my students' paper and they got work here, they got work there, it's all over the place, and I have no idea what the final answer is. Here, it's very easy to see when we find true, that's going to be our final answer. Okay?
Yeah, that makes sense. Huh?
It's making it, okay, great. Great. I'm glad I'm helping. Excuse me.
Then the last one's 30.
30. Okay, let's go take a look at that. Wrong button, hang on. Okay, 30. I got a million screens open. I keep touching the wrong button. Okay. All right. Let's take a look at this. It says add by until the literal coefficients ax plus bx. Huh. Okay. Add by. Okay, hold on. Add by uniting the literal coefficients ax plus bx. Oh, okay. What do you think they're saying right here?
To just add together ax and plus bx.
Okay. So that's what they're saying, but what they want you to find is they're really asking this question: which option, A, B, or C, are similar or equivalent coefficients or equivalent expressions? And by equivalent, you know what I mean?
Yeah.
Okay. What do I mean when I ask about equivalent?
Just another way of solving the problem.
It's another way of solving the problem. Okay, so like, for example, if I have the term 24? Give me 3 different ways I could write 24.
8 times 3.
Yeah, I could do 8 times 3. Yep, 8 times 3. What else?
48 divided by 2.
Yeah, 48 by 2. Yeah, you got it. Give me one more.
Plus 12.
Yeah, 12 times 12, right?
12 plus 12.
12 plus 12. Or 4 times 2. So these are all equivalent ways of looking at it. So when we look at something that's equivalent, what we're asking ourselves is what terms, what are factors? What are factors of 24? And factors of 24 are 8 and 3, boom. Factors of 24 are 12. Factors of 24 are 2. So the question now is, what are the factors of 8x plus bx? Well, x. So if I took 8x plus bx, and I know x is a factor, the opposite of multiplication is what? Division. If I divide x by each term, what does that leave me with? A and B. So A plus B times X is equivalent to AX plus BX. That makes sense?
Yeah.
Okay. So this is all based on the idea of what are the factors, factors, in each term. And we actually have this term called GCF, greatest common factor. And the greatest common factor in this problem right here is the X. And as a result, what we have back is we pull out our GCF right here, and what's left, we keep in the parentheses. So here, that X is our GCF, greatest common factor. Okay. So, although this is highly symbolic because we don't have a lot of numbers to work with, it's really the same thought process. Mm-hmm. Same thought process. What can we pull out? What can we factor out? And when we say factor, we say we're unmultiplying, we're dividing. Okay. So how do we feel about our time together today?
It was great. I appreciate you helping me out with this and becoming an electrician.
Hey, not a problem, man. Not a problem, man. I want you to do well. And then when you get there, man,
And,
I want you to.
I just wanted to ask if you.
Yeah, go ahead.
What'd you say?
I want to make sure you.
You knew any.
What's the question?
I just wanted to ask if you knew any websites that had like randomly generated algebra questions so I could practice every day.
Oh, similar to this? Randomly generated algebra
Yeah.
questions. I actually, off the top of my head, can think of a handful. I would just basically need to see if they don't need a password. Because I used to use them quite a bit about 2, 3 years ago. But you could do X a number a day, and then it will. Let's see if this one still works. Hang on, and we'll just stop thinking about it and just be about it. So, and if this works, I invite you to jump right in here. Google New York. Actually, not. Okay, Regents review questions. Let me see if it's this. Oh, I remember this one. Zern math. Right, okay, that's password protected. Hold on, it's another one. I remember. Hold on. See, the thing is, a teacher, what you do is you collect a bunch of websites as you are doing your thing, and you bookmark them, and you pick up 5 or 6 or 7 websites, and if you don't use it, you lose it. All right, so this is one. I like this one a lot, actually. This is called eMath Instruction. eMath Instruction. It's free, costs nothing, and you would be interested in Algebra 1. Yep. And this is the cool part. It has an answer key, and it actually has a built-in video. Okay, so that's one.
Okay, cool.
eMath Instruction. Okay, let me see if I can get you another one right quick. Brain Pop is actually, yeah. Brain and memory games. No, that's not what I want, actually. Actually, Desmos. I have not been here in about a year or two. This is cool. So, function. Nah, this is not what you want. It's more geometry. Algebra, extra credit problems. Let's see here, what's here? No, it's not what you want. Oh, IXL. IXL. Yeah, definitely. Okay. So with IXL, here's the only deal. It's password protected, but you can do up to 50 practice questions a day without logging in. And so what you'd basically do is you basically go to algebra, okay? And it gives you like a choice of different things to practice. Now, I'm going to tell you that my recommendation is for you to practice factoring, percentages, rates and proportions. You don't have to write this down because the video is going. Measurements, okay. Functions, specifically linear functions. And solving equations. Solving equations. And I think that's a good amount for you to review right there.
Go through that one more time.
Yep, let's go through it one more time. So okay, solving equations is what I said last. Okay, they can get much harder. Carlson earns $21 for each hour. Okay, and I suggest that you do. I didn't actually say linear inequalities, but that could come up. I'm not sure on your test.
Okay.
I said linear functions, definitely. I said measurement.
Okay.
Percentages and proportions, and lastly, factoring. Okay. There you go. That should keep you quite busy.
You said proportion too?
I did say proportions, yeah. And so have you ever been on this website before?
Okay.
Have you ever been on the website? This one?
No.
Okay. So this is how it feels when you go into it. It'll give you a questions answered, and it'll give you a time lapse. Again, it'll allow you to do 50 questions per day without logging in. So find the greatest common factor. So what I see is that I see Q to the third in each term. And I also see that there's a 9 and a 6 in each term. And I think I can divide 3 into 9 and also 3 into 6. So I would say my greatest common factor would be 3, Q, and then here's my Q. I'm gonna, excuse me, that's not what I wanted to do. 3, Q, and then I'm gonna put Q to the third. And all that other stuff, I probably should erase. And I'm gonna hit submit. Okay, but sometimes I'm not gonna get it right. And say I just put B in here. It's gonna tell me, oh, it's wrong. But not is it gonna tell me it's wrong, but it's gonna tell me what the concept was, what to remember, and how to solve it. So I used this website quite a bit before I transitioned to high school. So this is a really good website. Okay?
Okay.
All right there,
Well,
brother.
thank you for your time.
All right, excellent, man.
I'll send you an email for whenever I want to do another study session.
Okay, sounds like